Hello and welcome. This is Energy and Environment, Chapter 2, Part 1, looking just at a base introduction to our fossil fuels. When you talk about fossil fuels, in general, you're really talking about energy sources that are derived from a main common process, and then it's just realistically where in that process you find the environment or you find the materials that tells you if you have oil or coal or natural gas. One of the big things about fossil fuels is in the most general sense, they're renewable. There are fossil fuels forming right now today, say down in the delta of Mississippi and Louisiana. But the non-renewable point comes in the context of the fact that in our current system of use, we use it faster than it's created. It takes millions of years and certain environments to form, and we are using it within years and decades. Now, fossil fuels can exist in all three phases. They come in gas form, liquid form, solid form, and we do see conversions between. But remember, every time you convert, you lose energy, and you lose the quality of energy. We also find that some forms are much more concentrated or what we call a higher quality, such as liquid oil pumped directly from the ground, versus something that's more of a lower quality because it's a more diffuse source, and that might be something like tar sands. The big thing also with fossil fuels is that in the use, they are what we call a carbon source, which means they take carbon in a stored form and release it into the environment, very specifically into our atmosphere and also into our water sources. As I said, all fossil fuels really start as carbohydrates. They are formed from organic carbon. And what happens is you have the main source from living organisms, plant and animal material. When these living organisms die, they begin to collect and they begin to decay. Now, in the very base form, you get kerogen, which is your main starting source. If you begin to heat this material and you begin to put it into a higher pressure environment, then you can have a chemical transformation. And you will also have a heat process that allows for a change. And depending on how much heat, how much pressure, and how much time it is in this particular environment will depend on the final result of your fossil fuel. So when we look, we find that oil and natural gas are often what we call a high quality fossil fuel. You'll notice that we are talking about a naturally liquid or gas form. And remember, gas phases and liquid phases are your higher energy phases. Because these are your higher energy and higher quality, they also require more time to create, more heat, and more pressure. Along with that, you also need, and this is in the lower right hand corner, you need some form of environment that will trap. Oil and gas are fluids. They'll move. So you need to have an environment where you've not just created it, but then you have what we call a non-porous or an impermeable type of rock or material that in some way, shape, or form traps that gas and oil. Coal is a lower quality, although you can still have quite a power punch from it. But again, it's a solid material, and it forms when you take the raw organic material and you bury it, and again, you put it under heat, but not your highest heats. If you put it up too high, you essentially transform from coal to oil and gas. Within coal, we find that there are ranks or stages of formation, and those simply indicate how much time has passed and how much conversion. We go from peat, which is basically your organic material. If you went out walking in the wetlands today, you're walking in peat, to a lignite, which implies some formation, your water's starting to be pushed out, but it's still not a lot of hydrocarbons have been transferred or transformed. Then you get into your bituminous, and the highest quality coal, the ones that will give you the most power punch, if you will, is your anthracite. A note, we'll talk about this more, is that coal can also be gasified to form a synthetic fuel, and that's often actually looked at as an alternative for the transportation sector. And it can also be liquefied. There are certain power plants that will use this crude oil. The problem is it takes a lot of energy to make those forms. Remember that transformation process? And it's not very cost efficient at this time. Another form is what you hear of oil shale, and this is actually a sedimentary rock. It's very rich in kerogen, but it usually wasn't under the same conditions as coal or gas or oil. We usually burn it like coal, all right, although sometimes it can be, again, melted and processed to form a different fuel type. I have a website here, and I'll put it in the class as well, that has a very nice little overview of oil shale. And in fact, that same site is good for tar sands. Tar sands are, if you've noticed, I've been putting these in lower and lower quality. They're very dirty because there is oil and hydrocarbons, but they're mixed with sand, clay, and I warn you, clays can be very toxic. Okay? They often trap arsenic, lead, and other elements easily within their structures, and other metals as well. So usually to get the fuel, we have to burn first to actually extract the oil, which is why it's often called a very dirty process. And again, you take a lot of water and you take a lot of energy just to get that energy. It used to be that tar sands were too inefficient. But now, as our technologies have changed, and honestly, as we're running out of other sources, they start to become attractive.